This lesson we will be looking at domain and range, but now what happens if you don't have a graph? So you can't maybe visually see what x values there are or what y values there are on the graph, but maybe you're given x and y in some other way, and we're going to see how to figure out the domain range in those other circumstances. Okay, so we may have situations where the relation or the function is discrete, and by discrete we just mean it takes on a whole number of values. So maybe there's points, there's 5 points, or maybe there's a table of values itself with a certain number of values in the actual table of values. And in each of these situations, when you have just a certain number of values that you can count, we'll just list out all the values. That's all you need to do. So there's no fancy technique here. It's just literally listing what you have. So you do have to go through and list it all. So in this case, I'm listing all the years of birth. That's the domain. That's the input. And then the output in this case is the life expectancy. So if you're born in 1900, your life expectancy is 47.3 years old. If you're born in 2000, your life expectancy is 77 years old. So yeah, I'm just listing all the years here. Don't list the years in between. It's just those 6 years that we have in our table of values. So those are the 6 inputs that we have. And for the 6 outputs, it's 47.3, 54.1. And you'll see with this, I don't even need to do that fancy notation where I had like x as an element of r. Because in that case, we're saying like we're covering all values, and then we'd usually say like between a couple of numbers. But here we're not covering all values. We're just covering specific values. In this case, these specific values that we're writing down. Okay, and lastly, we have 77.0. And again, I use the squiggly brackets. That indicates a set. So it's the set of those 6 numbers in each case for the domain and the range. Okay. So that's the easy case. You just have a list. You just write down what you have. You might be given a function. You might not have the graph of the function, but you might still be able to figure out its domain and range based off what you know of the function. And as we spend more time in the course, you'll be seeing other kinds of functions, and you'll get familiar with other kinds of graphs and such. What we have here, though, is a quadratic. And so it maybe has been a little bit of time since you've spent time with a quadratic, but you can just make sure you remember, well, what do we know about a quadratic in this form? This is our vertex form. So it's not like we need to draw a fancy graph for this. All we need to remember is that the vertex in this case is just kind of those key numbers from your vertex form. You just have to remember that the x gets flipped. So instead of -3, it's a 1, or it's a +3, and then you have the 1. And we'll spend more time with these kinds of graphs. But yeah, just having a familiarity with the function, in this case the quadratic, which you spent time with before. Then we can use that to get the vertex. So the vertex is at 3, 1. I'm just going to draw a point there. And then, well, it's a quadratic, so it's a parabola. So it either goes up or it goes down. So the question is, which way does it go? Well, that's where we look at the lead coefficient, or the thing in front. Is it positive or is it negative? Well, in this case, it's positive. There's no negative sign, so it opens upwards. And the key thing here is just, well, that tells us the vertex is a minimum. So it means that we're going to go up from that smallest value. And so now we can go ahead and go through the domain. So for the domain, what we can actually do is, well, the graph keeps going to the left or to the right. So pretty much always for quadratics, it's going to be any real number. There are no restrictions. There is no x value that you can't plug in. And for the range, this is why we want the picture of the graph. It's because we need to know, are we reaching a minimum or a maximum? So in the case of this, we have a minimum, so it means that we could be any real number, But more specifically, it needs to be any real number that's bigger than that minimum or equal to it. And so that minimum was an y value of 1. So we're going to say we're greater than or equal to that y value of 1. And so there we have it. That's our range. And again, in those squiggly brackets, the curly ones. Okay, so there we have it. That is our domain and our range. What you can also do is, if you have a function, maybe it's something you're familiar with, maybe it's something you're not familiar with, just ask yourself kind of the reverse question for the domain, let's say, is what x value could you possibly not plug in? Because for the most part, if you have an equation, you could plug in any x. And that's why typically we start with, when we're doing domain, we start with x could be any real number. But depending on the actual equation, there may be some situations where a particular x or particular x values won't work. And that's what we need to be careful of. And so, well, what might possibly happen? Well, in the first situation, what could possibly happen is you have a fraction, and what you can't do with the fraction is you can't divide by 0. And so we just need to figure out, well, when could you possibly have this division by 0 happening? So you could have that division by 0. Well, just set the bottom equal to 0. X plus 3. If you rearrange for x, that means x would be negative 3. So if x were to be negative 3, you would get 1 divided by 0. But we cannot calculate 1 divided by 0. So what we need to do is basically make sure that x cannot be negative 3. We don't want to plug that in. So in our domain, we're going to have every possible real number except for that one number we can't be, the negative 3. So that's our, what we call restriction. We'll look at that actually more in a future unit too. But that's the first way that you can look at, well, what can't x be? If we have a fraction, think of dividing by 0. The next situation is a square root. Well, if we're thinking about square rooting, we need to keep in mind, well, what can you actually plug into a square root? And what we need to be careful of is, in a square root, the number inside the square root must be positive or 0, not negative. Yeah, you definitely can't plug in a negative. If you were to try to take the square root of negative 1, well, two numbers multiplied by themselves, or like a number multiplied by itself, will always be positive. You can never get a negative answer, so you can't have a negative inside a square root. At least for our time right now in math. Eventually, there are things you can do, but don't worry about that. For our purposes, throughout this course and throughout many future courses, there is no possible negative answer. And so we need to make sure, well, x minus 1 can't possibly be negative. We want to make sure it's greater than or equal to 0. So we have this statement. X minus 1 must be greater than or equal to 0. And we want to make sure whenever we're writing our domain or our range, we want it in terms of x or just y. So you can actually rearrange what we'd call is this inequality, just like you would an equation. And for the most part, inequalities can be arranged pretty much the same way as equations. So I can move that 1 over, make that 0 plus 1 to balance it, adding 1 to both sides, which gives you x is greater than or equal to 1. There are certain finicky situations where you do have to be careful, but for the most part, we aren't going to look at those. But in the future, you may see those. So what we can say now is that x could be any real number, and then we just have to take into account what it can't be. And that's where we use this inequality, x is greater than or equal to 1, what we just found out there, which makes sure that if you plug in something into the square root, it's going to be positive. So if I were to plug in the number 1, well, 1 minus 1 is 0, so that works. Or if I had to plug in something bigger than 1, let's say 10, well, 10 minus 1 is 9. You can take the square root of 9. It's just 3. All right. Let's continue onwards. So now we're going to work with this question here where we're determining the range based on a given domain. So let's say you only had these inputs, -2, 0, 1, and 4. What would be the outputs then? So in this case, even though it's like a quadratic, if you were to plug in any x value, you would be able to get a bunch of y values. We just have these specific things that we're plugging in. So what we need to figure out then is just, well, we basically need to figure out every single value it's equal to. So we need to figure out what is f of -2. Plug it in, get an answer, and then once we get all those outputs, we have the range. So yeah, it's just going to be a number of calculations, but calculations that are fairly straightforward. So we get 17 when we plug in -2. If you plug in 0, well, you just get 0 squared, which is going to be 0, so that first part disappears. -3. F of 1, 5 times 1 squared, -3, so that's just 5 minus 3, which is 2. And the last one is 4. And so the last one, when you plug in 4, it's going to be a little bit bigger. You get 16 times 5, which is 80 minus 3 is 77. Okay, so now we can write the range. Just in terms of kind of like, let's say, nice math, when we're listing our domains and ranges, we like to list things from least to greatest. So even though these answers, I inputted the domain, I got 17, -3, 2, 77. It's not from least to greatest. So, but what we can do when we actually list our range is we can still list it from the least to the greatest. So -3, 2, 17, 77. So the order of the numbers does not necessarily correspond directly to which element from the, let's say, the domain matches up with the range. So it's not like they're in order of that. They're just in order from smallest to greatest. So that's just one thing to note. So if you can, write from smallest to greatest whenever you're doing domains and ranges. Don't worry about the order of the actual answers you got. All right. And let's take a look at this last situation, a word problem. And so we want to use those previous methods just to get a sense of what the domain range is, but we need to be careful of what is the actual physical situation, what makes sense. So don't just think about calculations, think about what is going on here. So we have a skydiver. She releases her parachute, falls at a constant rate to the ground. So let me draw a skydiver. This is the person, they're skydiving, they're falling down. And the ground is somewhere down here. And eventually they get their parachute and they're going to fall down all the way to the ground. Okay. And her height can be modeled by the function h of t is equal to 1,000 minus 5t. That's a linear function, it's a line. But what's important is, well, we'll see in a moment, but that's how we're going to analyze it, is taking into account the fact that she's falling. So we have t is seconds, h of t is the height in meters. Okay, so we want the domain and the range. Let's just focus on one at a time. Let's start with the domain. Okay, so if we were to do a domain, if we're looking at this h of t, it would look like you could plug in any value for t. You could plug in the number 100, you could plug in the number -1,000. It would work. You would get an answer. So you could get an answer, but what actually makes sense in this situation? So for the domain, we need to keep in mind we're looking at time. And well, for time starts at 0. You're not going back. She wasn't falling before she jumped out. She only starts falling after this particular situation starts, where the function only applies at the time 0. So that's going to be our smallest value. That's going to be the start of our domain. So keep in mind the actual situation. So keeping that in mind, the actual situation, we need to think about, well, when would this situation end? Well, the situation would end when she reaches the ground. But then how do we figure that out? How do we know when she reaches the ground? Well, that happens at a height of 0. And we have a function. So what we actually want to do to start this off is we want to figure out, well, we're going to set the height equal to 0. We have the function, 1,000 minus 5t. Set that equal to 0. And we just want to solve for t. As in, we want to solve for the time. So I'm just going to move the 5t over, divide by 5. And if you do that, 1,000 divided by 5 is just 200. So when she reaches 200 seconds, well, at that point in time, she has hit the ground. So now we can actually write down our domain. So let's write down the domain here. So the domain is just going to be one other thing to take into account. We have a word problem. Our function is h of t. It's not f of x. So we're going to write our domain in terms of our given variables. So t is now an element of the real numbers. That's our input, the t value, the time. Our output is the height. And so we're going to say t is any real number such that, well, we're starting at 0. We could include 0, so I'm going to do less than or equal to. And then we're going all the way up to 200. And we're going to include 200 because that's the exact time she reaches the ground. So it's anything from 0 to 200. Okay, so that's kind of the first part of the problem, is just the domain. All right, the next part of the question is, well, the range. So the range we need to think of in terms of the physical situation. What is the highest she is, and what is the lowest she is? So we need to think in terms of max height and minimum height. Well, the minimum height, well, we're saying, like, this function ends when she hits the ground. So the minimum height is ground level. We don't need to actually do any solving in that case there. It's just 0. Once you reach 0, you're at the bottom. But what is the maximum height? Well, the maximum height we need to figure out. But how do we figure that out? Well, when would she be at her highest point? Well, at the very start. And that would be at time equal to 0. And then we could figure out what that is. So if we calculate h of 0, substitute in time equal to 0, well, into our function, that's just going to be 1,000 minus 5 times 0, which is just 1,000. So that's the max height. So we know she's starting at 1,000 meters, slowly falling down all the way to a height of 0. So she's going from 1,000 to 0, or again, when we write our actual range, we like to go from least to greatest. So we're going to say, I'm going to say h of t, so the h for the height is a real number such that from least to greatest, the least is the minimum 0, all the way up to, well, I'll do h of t in here. You could do just h, I would be fine with that, as long as it's the variable or part representing the height. So don't use y, because we never had y in the equation. So all the way up to 1,000. And there we have it. That is the range. So be careful of word problems. Make sure you're taking into account the physical situation, and just imagine, like, what's actually happening. In this case, we're falling down, so we're looking at the starting point all the way to the ending point to figure out both the domain and the range. And so that's a look at domains and ranges just in general in situations without a graph. So keep in mind, those different methods, listing them out if you have just a discrete relation, which is just a list essentially, picturing the situation, or just figuring out what can't X or Y or the input or output be.